Thank you for joining us at the NLP Summit. I'm Stefan from Vendr, and I'm excited to present to you today. So data is often unstructured until you really need it to answer business questions. And at Vendr, we were in exactly that situation. So we collect lots of data on transactions, but it's stuck in documents. And we want to get that data out to unlock important insights for our customers. So the unstructured data that I'm talking about, it comes mostly in the shape of order forms for software as a service, or SaaS as we call it. Examples of SaaS are tools that many of you probably use every day, like Slack or Salesforce or Zoom. And order forms are typically PDF documents that have plenty of information, such as the agreed price and the specific items that were purchased. Getting that specific information out of hundreds of thousands of documents allowed us to compare pricing and then make valuable recommendations to our customers on the price that they should be paying. Instead of building a capability to extract this structured data from these documents ourselves, we partnered with Extend to provide us the platform to extract this data quickly. This then allowed our data science team to really focus on prompt engineering, making corrections to the data, and building on that data set. Today, we will jointly show how Extend's platform uses LLMs to extract this data, how we use the platform, and then how we dealt with some challenges that we encountered along the way. This hopefully will give you a jump start into your journey to extract structured data from your documents. Now, I will pass it off to Kushal from Extend.
Awesome. Thanks so much, Stefan. Hey, everyone. I'm Kushal, the CEO and co-founder of Extend. And today, I'm very excited to speak to you about what we're doing and some of the challenges we've encountered when building large-scale document processing systems. So at Extend, we're building a modern document processing platform that enables customers to turn messy, unstructured documents like PDFs, images, and Excel files into a competitive advantage. And we do this by providing them with an out-of-the-box toolkit that companies can use to build in-house custom document processing for a variety of use cases. Everything from automating internal flows for gaining operational efficiency, increasing customer NPS by speeding up user-facing features, or even building entirely new products. So OCR, IDP, these terms have been around forever. Right? There's hundreds of tools out there on the market. So the first question we really have to ask ourselves is, when should we build something with LLMs, and when should we use, the hundreds of solutions that exist out there based on traditional OCR? Well, broadly speaking, they're broken down into two categories. The first is generic OCR tooling, like AWS TextRact, Google's OCR product, Azure Document AI, and there's tons more. Every one of the major cloud providers has one. The second category is domain-specific point solutions like W-2 tax forms, receipts, invoice processing, and a lot more. Well, our first recommendation is if you can use one of these solutions, you really should. Don't bring LLMs into the picture. LLMs are not a silver bullet, and they can introduce a lot of complexity. So if your use case is relatively simple, pretty standard semi-structured documents, you only need a few basic fields, then any of these major options would work. Oftentimes what we do see is these legacy solutions can fall short if they lack the capability to handle extremely complex data and requirements, or they can't be used to customize and power the unique experiences that teams are trying to build. And so in these cases, bringing it in-house with LLMs will enable the full customizability you need. And that's exactly what we've been able to do with the Vendr team. However, in our experience, there's a few landmines that companies run into when deploying LLMs for mission-critical use cases. The first is extremely long go-live periods. How do we teach LLMs the different ambiguity, complexity, and variety in our documents, but in a way that we're not spending months iterating and firefighting edge cases? The second is, as we all know, AI systems are non-deterministic and can fail in unexpected ways. So how do we confidently deploy into production and sleep well at night, knowing that hallucination isn't going to have adverse downstream impacts? And the third is Data complexity continuously increases, business requirements continuously change. So how do we build a system that can adapt to that without requiring tons of maintenance over time? So let's jump in and look at what typical long go live periods look like and how customers can avoid falling into that. The first step is, LLMs, to be successful, they need good data and great context. And we'll break down each of these parts. So what do we mean by good data? Well, documents, as we all know, can come in so many different shapes, sizes, and formats. And so you need a robust pre-processing pipeline to properly format this data before you pass them into the models. So how are we going to handle skewed documents, for example, upside down ones, rotated ones, blurry ones? What if our documents can span hundreds of pages? If that overloads context windows, we're going to need to introduce chunking. But then what if we have tables and context that can span multiple pages? How are we going to handle that? When should we use something like multimodal versus text? And in our experience, we can't rely purely on multimodal models because they tend to hallucinate quite a bit more. But there's certain features and characteristics of documents that they can recognize, like signatures and strike-throughs. So how do we combine these two together? And if we are using multimodal, how do we deal with image resolution issues and determining the best one, for various images, JPEGs, PNGs that we might get? And how do we do this all in a way where, as we have complex tabular structures that come into play, complex data requirements, the edge cases can spin off kind of into infinity. And so the first step of any good document processing solution is cleaning up the data as it comes in and building a robust pipeline to handle it. And in our experience, what we've really done at Extend is using traditional OCR techniques to rotate, skew, remove a lot of the noise, crop documents so that when we feed them in, the LLMs have good data. The second is great context. What does great context mean? Well, historically, a lot of the training has been done by technical teams and data engineering teams. But with LLMs, we see this paradigm being flipped. Because as the models improve, the challenge is no longer, can we pull the text off the page? It's, can we teach the LLMs about the ambiguity and requirements in these documents and give them the right context to be successful at that task? So what we're looking at here is an example of financial documents like sales contracts and invoices. And when we say, hey, find the total price, what does that actually mean, right? Is that the list price, the price after discounts? Do we include taxes in it? What if there's strike-throughs on the pages? How should we handle that? And for the right context, when teaching humans to do this task, we wouldn't just give them this file and say, go find the total price, right? And so the first step of even building a lot of the document processing is giving the LLMs the good context in terms of being able to disambiguate between the various data fields that are there and how to actually properly find that. And then second is, how do we break up the problem into pieces so that, when we give a human this job, for example, they first would go through and say, is this a valid file? Can we even see this? Is it legible? Is it blurry? Is this an invoice or is it a picture of a dog, right? Is this junk data? And if it passes that, which pages should we even look at to find the total price? And where on that page is the total price? And once we identify the section that it's coming from, how do we normalize that value so we can use it downstream? And so what we really see be successful here is providing no-code and low-code tools to both technical and non-technical domain experts in your company so they can collaborate, where the domain experts understand this runbook better than anyone. And so giving them low-code tools to teach that ambiguity to models is extremely powerful. And then we're going to want to operationalize that runbook in a way where we can first get documents in, pass them through data classifier steps, and then data extraction steps before processing them downstream. If we don't operationalize these models and these workflows in this way, we're relying on the models to make logical leaps, which can introduce a lot of errors. And these low-code tools speed up the time to go live by weeks or even months and significantly reduce the maintenance cost in the long run. The second problem that we have to solve is, how do we choose the best models for the job? So model optionality is really important because performance can mean different things. Is it high accuracy? Is it low latency? Is it low cost? And in our experience, the best way is to start with something like OpenAI or Anthropic by default, which gets you pretty far. But then you're going to want to customize and test between the different ones, because we've noticed Claude, for example, is better at certain visual tasks. Open source is obviously going to be better on cost. Smaller models are going to be optimized for latency. And so the right way to handle and determine the best model for the job is you got to make sure you have eval sets, because without eval sets, it's going to be really hard to know, hey, are we introducing regressions when we bring in different models? Are we seeing dips in performance on certain fields or improvements on certain fields? And so without a system like this, a lot of time is wasted in brittle trial and error methods. Once we get that into a good spot, how do we use LLMs in cases where accuracy matters a lot? Because as we all know, AI is definitely not 100% accurate. And so on day one, what we typically see is you can get probably 90% performance, but it's hard to deploy into production for mission critical use cases without the right guardrails in place, right? So if we hit 90% on day one, how do we catch the remaining 5 to 10% and flag those for review? And we'll see the vendor's team's unique solution here. But we've also done this in Extend in a few ways by, one, helping determine model confidence. So we can't ask the LLM for its confidence. That typically doesn't work well. But a good approach is using something like logprobs of the tokens that are outputted, asking the model for citations and chain of thought, and then interpreting uncertainty signals within that. And then we're also experimenting with some techniques around LLMs as judges, where you have teacher-student models that can correct and check each other's work. You want to augment all of this with data validations, which are really important. For example, if you're pulling invoice line items, do the total of the line items add up to the total of the invoice? And if not, you probably want to flag that for review. And of course, you want to augment all of this with robust human-in-the-loop tooling, where humans can come in, have oversight over the entire process, review results, make corrections, and add in any notes as needed. And those corrections are valuable signals that need to be monitored over time, so you can see which fields are struggling and focus on improving those. Now, how do we continuously improve this system at scale? Because our data is going to evolve. And fine-tuning is not a silver bullet. We see a lot of teams jump to that, but you can get degraded performance when you do that. Rather, first, monitor your data in production and observe it. Add various edge cases to those evaluation sets, and then start by optimizing your prompts and iterating on those. Feed in few-shot examples, and that's typically good enough to get you from 80 to 90 to all the way up to 95%. And then to achieve that last bit of performance that edge case prompting cannot fix, then you would want to explore something like fine-tuning. But again, it's not a silver bullet. In our experience, data classification is a great fit for fine-tuning, but data extraction is a bit more challenging because chunking and some other problems with overfitting can come into the picture. And of course, evals are the basis for all of this that you're going to want to use to test your fine-tuned models in production. So we've successfully used these tools to deploy LLMs on complex mission-critical flows at startups and enterprises. But again, these tools are just that, tools that still require experts to operationalize them and apply them to their unique data and business requirements. So I'm excited to pass it off to Mark over at Vendr, who are one of the most capable AI teams we've encountered, to show you how they're able to build on top of all of this and deliver value to their customers. Over to you, Mark.
Thank you, Kushal. In this final section, we will discuss how Vendr has used LLMs and human review to create structured catalog data. Here we will focus exclusively on order forms and how we convert these to documents. We will argue that entity mapping is central to having a usable document repository, and we will share challenges and solutions encountered in this area. We will also touch on some techniques for deriving other fields. Our objective is to share approaches and considerations in creating your own structured data. This slide shows an example order form from the SaaS supplier Mode Analytics. Let me introduce the key entities. First, the customer is the entity purchasing SaaS. Second, at Vendr, we use the term seller to designate the entity which is selling SaaS. There are three typical cases for the seller: a company which sells its own software, such as Mode Analytics selling Mode; a parent company which sells software for a subsidiary, such as Salesforce, which owns Tableau, selling Tableau Cloud, and a reseller sells SaaS on behalf of another company, such as a company reselling Atlassian Confluence. These distinctions can be difficult to infer from an order form. Third, we use the term supplier to describe the software entity or brand which produces the software. In these examples, Mode, Tableau, and Atlassian are suppliers. Order forms typically have a top section describing the entities and the overall contract duration and cost. There may also be line items describing pricing for products as seen in the bottom of the form here. I want to highlight why entity mapping is critical for document processing. Structured data may be consumed by humans or systems. Our own back office tool shown here is an example of a human-facing tool where staff can search for relevant documents. A document's relevance may be heightened by recency or having a total contract value similar to a proposed deal. If we misclassify the supplier entity, 3 issues may arise. First, the users may lose trust due to incorrect results. Moreover, users may fail to find highly relevant documents entirely if they are misclassified. But lastly, data aggregations such as the average contract value may be incorrect and misleading. Now, you might ask whether one could use LLMs to do this research in real time rather than pre-processing with human review. We feel relying entirely on real-time LLMs would result in too many mistakes, including unknown unknowns. Documents are not always clear, and complex seller, supplier, and customer relationships occur, which we need to figure out in advance. In our case, we would have error rates above 5% without pre-processing and fixing the data. Moreover, these errors are not always random and may occur in clusters. Therefore, we argue that entity identification is a critical pre-processing step. Once the entity identification is correct, we have a starting point for further iteration on other field values. So let's talk about how we do entity recognition. We need entity recognition for customers, sellers, resellers, and suppliers. Step 1 is to write and iterate on prompts to extract these entity names from documents, with the goal to identify the correct names. An example prompt is shown here. But names can have multiple variations, such as the SaaS supplier HighTouch shown here. As you can see, some LLM extractions returned Carry Technologies doing business as HighTouch, and others returned HighTouch directly. With a document catalog, recognizing an entity means not simply identifying a name, but mapping to the corresponding entity in our catalog. In this case, each variation of HighTouch must be mapped to a single catalog entry. Based on testing thousands of documents, we find 2 types of mapping challenges. First, an LLM may return an incorrect entity name. It might return unrelated text or confused names in the document. In fact, even a human reviewer may have some difficulty distinguishing entity roles. So when we review, it's always nice the LLM has taken a first pass. Moreover, even if a name is extracted, mapping that name into the catalog presents several additional challenges. String overlaps may result in false matches. eShares mapped to eSha Research and was not consistently mapped to Carta. Entities might not already exist in our catalog in advance and have to be created. And entity names may change over time due to corporate actions such as mergers and acquisitions. With these combined issues occurring more than 5% of the time, some human review is today necessary. We wanted an operational process where we could fix data. Our initial solution was to do synchronous review in the Extend UI for a sample of documents. But we needed to make subsequent corrections, so we also added document reviewing to our own back office tool. Still, we were confronted with our largest problem: how to ensure correct entities without reviewing every document manually. The document process we described so far treats each document separately. Learning from our growing document repository occurs when we leverage shared information. Once you have a document library with structured data, you are in a better position to ask the question, which document is not like the others. Perhaps if a document is dissimilar to others for a seller, it is incorrectly identified. We hoped that this could target our human reviews, avoiding a review of every single document. If we could characterize each document in a document space, we hypothesized we could determine whether an entity was misclassified and perhaps also predict the entity directly. We used OpenAI to calculate embeddings from each document's text. We then calculated the cosine similarity among documents and identify which documents fall outside a cluster. First, this helped us identify the incorrect seller, resulting in targeted reviews with the anticipated corrections. A second finding was documents which were not order forms at all, and those required a correction too. But two other cases arose which did not directly translate to corrections, but were also quite useful. Sellers changed their document format over time, and embedding differences may reflect different document lengths, signifying an appendix or additional attachment. Armed with these findings, we added a short embedding limited to the first 450 words, and now use different embedding lengths for different purposes. In short, document similarity allowed us to target review efforts, improve our structured repository, and develop confidence in our entity predictions. As we use document similarity to target the reviews, we realized that it is important both to correct the data and to affirm the data. An affirmation means a human confirms the data. This affirmation may result from a correction or a deliberate act without changing the data. We represent an affirmation in our UI with a small green check mark, which does not distract from the core data. By recording these affirmations, we identify data which is more highly trusted and prevent subsequent LLM extractions from overriding previously reviewed and approved data. Still, there are challenges remaining for us, as we want the document repository to be durable over time. For example, corporate actions such as acquisitions and name changes remain a challenge for an active document repository. So far in this presentation, we have dwelled upon entity mapping. Before wrapping up, I want to highlight best practices for other fields. Most important is to create clear rubrics tackling important issues for each field. A rubric describes the rules to be applied when deriving structured data from documents. It describes the semantics of the fields and the process for handling ambiguity. Our operations team created a rubric for every field. It is important for your rubric to handle missing values, inferences, and change. Here are some examples our rubrics needed to handle. Human errors in documents. Yes, the year in the document was 224, but that is not what we want in our structured data. Inferences around dates or amounts. We might have a contract start date and a term length from which we infer the end date, even though it's not in the document. Changed relationships. We have to make a decision whether to assign the document to an entity which it would now pertain to but did not exist when the form was created. And augmentation. Our customers want to know whether a contract auto-renews, but that might not be covered directly in the order form. In summary, in this presentation, we've dived deep on how LLMs and hybrid human review has accelerated our ability to digest more than 100,000 documents. We feel this effort has been substantially faster and more successful than prior art with human coding of documents. We hope sharing these experiences with tools and processes can jumpstart your journey. We are optimistic about the continuing application of these techniques and the benefits of hybrid strategies combining LLMs, natural language processing, and human reviews to create reliable and usable structured data. Thank you.